Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to say thank you to Session Chair to give us opportunities to share what we already done in our research with the title and estimation of electrical energy saving for lecture building at Universitas Andalas using daily electric need pattern. This research conducted by me and also Mrs. Vera Pujani, Ms. Elsa Juliani, and Mr. Refdinal Nasir, and we present it in Conference on Innovation in Technology and Engineering Science 2020. This is the outline of our presentation. First, we gonna tell you about our research background, and then the research problem, and we come with the objective of this research, method that we use, result, and the last one is conclusion. The background of this research. There is an issue at Universitas Andalas as a public university that they has to spend 720 million rupiah per month for their electric bill. So in the campus area, we can find a lot of notice put in every building to give us a warning, to campus member on how they use the electric wisely. Meanwhile, in the definition, energy conservation is considered as the efficient and rational use of energy without reducing essential energy use. And also, energy management is an effort to regulate and manage energy use as efficiently as possible in building without reducing comfort level in the residential environment and productivity in the work environment. As educational institution, the core business of Universitas Andalas is teaching, or we can also say as a lecturing activities. It's been arranged in the campus academic schedule, which also regulate campus activity for each month, such as any month for regular lecture or any month for exams. Based on the situation, it need to obtain a pattern of ideal daily consumption energy need for various kind activities at Universitas Andalas, especially in their lecture building during the lecture period, exam period, and lecture break. So based on the background, we can define that our research problem is how to estimate daily electric need for lecture activities at Universitas Andalas. So this is the three objectives that we need to achieve in this research. First, we need to obtain a pattern of ideal daily energy consumption need during the lecture period, exam period, and holidays at Universitas Andalas. And then the second one, we do a comparing real-time measurement and estimation daily energy consumption for lecturing activities. And the last one, we define the percentage of energy loss during the lecture period, exam period, and holiday at Universitas Andalas. This is the method that we use in this research. First, we do a data collection, and then the next step we do calculating base power and energy, and then we do a measurement for real-time energy use, and then we calculate the prediction or estimation of energy consumption, and then we do comparing the prediction of energy and the prediction and measurement, and the last one we do analyzing. This is a method that we use to calculate an estimation for daily energy use in every room at a lecturing building. So we only consider three electric equipment that settle in every room at Universitas. The first equipment is a lamp, and the second one is fan, the last one is projector. Okay, for real-time measurement, we build a system like this. Every on each building we put a measurement unit that connected to the internet network that can be accessed through the internet. Okay, for real-time measurement, we use the energy monitoring that display as dashboard. This is the visualization of the dashboard. Okay, this is the result that we have for estimation power usage during the lecture period. We calculate from Monday into Friday. We do not consider Saturday and Sunday as a lecture period. Based on the graph that we can see, the pattern is the power usage is start from 7 to 12, and then we have a break from 12 to 1, and then from 1 to 6 p.m. there's still still a lot of use of power usage. Okay, the second graph is how we compare an estimation and current usage on Wednesday during the lecture period. The blue line is an estimation, and the red line is current usage. As we can see here, there is the current usage is still high compared to an estimation. Okay, this graph is also still comparing an estimation and current usage on Friday during the lecture periods. There is something we need to be highlighted. During the break time, it means it starts from 12 to 1, usually for used for Friday prayer. As we can see on there should be no activities. It means no electric usage need to be used at that time. But as we can see here, what happened to the current usage is still consume a lot of power or energy. Yeah. Okay, this is the estimation power usage on workday during the exam periods. During the exam, we can see the pattern is like this. Sunday and Saturday is no activities because in our schedule usually we do not use Saturday or Sunday for exam. This is the estimation power usage on the workday during the exam periods. As we can see here, on Sunday, on Saturday, there is no Okay, this table provides information about daily energy usage rate, comparing an estimation using use pattern and existing condition. As we can see in the table, there is 3 sessions: first lecture period, second exam period, and the last lecture break. That's starting from Monday into Sunday. As we can see here, for lecture period on Wednesday, it has the highest number, it 28.5% loss. And then for exam period, we can find a minus value here. This is happen because during the exam period, we consider that exam will be held in the class, but what happened in the real condition, there is no lot of exam is not due in the class, so that's why the current usage is less than estimate. For lecture break, this is quite interesting. We can find that a lot of loss have occurred at that period. That is because usually in lecture break there is no class activity, but what happened in the real condition, there is still a lot of other activity. This is because maybe student do an activity in the class, maybe extra activities during the lecture break, or maybe they forget to turn off all electric equipment and they let it turn on all the time. Okay, this is the conclusion of our research. First one, outside the working hour, the real-time power value is greater than required pattern value, and it can be caused by negligence in energy management. Second one, pattern of energy consumption needs on the lecture day is different for each working day, where the real-time power value is greater than the pattern power estimation. And then we found that the pattern of energy usage during the lecture break, it has a power value that's quite large compared to the values of the power need pattern due to illegal or unregistered activities and negligence in energy management. And the use of electrical energy is currently quite efficient during the working hours. However, there is still lots outside working hours during the lecture periods. Electrical energy is the least efficient on lecture day with percentage value from 55 to 75%. Okay, that's the end of our presentation, and thank you.